Now we are looking at the miscellaneous example of the complex number and quadratic equation chapter. First is the conjugate of this. How you are going to find out? First we will solve it. We'll try to multiply these two, and you get the result as 12 plus 5i and 4 plus 3i. Now multiply the numerator and denominator by the conjugate of 4 plus 3i, that is 4 minus 3i. What you get? In the denominator you will get 4 square plus 3i minus 3i whole square, that will be 16 and 9, and above you will get 63 minus 69. So 63 by 25 minus 16 by 25i. This is the solution. Now example 13, find the modulus and argument of the complex number 1 plus I by 1 minus I and 1 by 1 plus I. So 1 plus I by 1 minus I, multiply the numerator and denominator by 1 plus I. You will get the result as I, actually 0 plus I. So now 0 needs to be placed as r cos theta, because 1 is the coefficient of I, so 1 will be r sin theta. You get r square, you know that this you have to square and add, so r is equal to 1. What will be cos theta? It will be equal to 0 and sin theta equal to 1. So theta is what? Theta is pi by 2. So the modulus is of course 1 and the theta is pi by 2. What about 1 by 1 plus I? Again multiply the numerator and denominator by 1 minus I. You will get this half minus I by 2. So half is your r cos theta. This minus half is going to be r sin theta. Square and add. R is going to be 1 by root 2. Cos theta is equal to 1 by root 2. And sin theta is minus 1 by root 2. Sin theta is minus, that means theta is going to be minus pi by 4. So the modulus of 1 by this 1 plus I is equal to 1 by root 2, and the argument is going to be minus pi by 4, as you see here. Next is x plus iy is equal to a plus ib by a minus ib. You have to prove that x square plus y square equal to 1. You know that x plus iy is this, so multiply numerator and denominator by a plus ib. A plus ib, a plus ib. So you get this a square minus b square plus 2abi by a square plus b square. Separate them. Now x minus iy is what? This will be the conjugate of this. So it will be what? It will be equal to a square minus b square by a square plus b square minus of 2ab square plus b square. And just you have to multiply these two, because x square plus y square is what? This x plus iy minus x plus iy into x minus I. Multiplication of this is going to give you x square plus y square, and you have to multiply this. You get the value as 1, because all will get cancelled. Example 15, find real theta such that this is going to be purely real. So first let us simplify it. Multiply the numerator and denominator by 1 plus 2i sin theta. You will get 1 plus 4 sin square theta in the denominator, and here you can combine these two and this two. So this part and this part, this is the real part, this is the imaginary part. Means except I, 8 sin theta by 1 plus 4 sin square theta is the imaginary part. But the question is that find real theta such that this is going to be real. So imaginary part has to be 0. If this has to become real, imaginary parts needs to be 0. So 8 sin theta by 1 plus 4 sin square theta, this is going to be 0. So 8 sin theta is 0, 8 cannot be 0, so sin theta is equal to 0. This has a general solution of theta is equal to n pi, where n belongs to the capital Z. Next, it convert the complex number this in the polar form. We know the value of cos pi by 3, this is half. Sin pi by 3, that is going to be root 3 by 2. Just place the value and take 2 in the numerator here, and multiply the numerator and denominator by 1 minus root 3i, 1 minus root 3i. You will get something like this. So r cos theta is root 3 minus 1 by 2. R sin theta is root 3 plus 1 by 2. Then when you combine them, square and combine them, you will get r square equal to 2, that is r equal to root 2. Which gives you cos theta as root 3 minus 1 by 2 root 2, and sin theta is going to be root 3 plus 1 by 2 root 2. So theta is going to be pi by 4 plus pi by 6, that is 45 degree plus 30 degree. 75 degree actually. How you are going to get it? Just let me give you an example that cos 75 degree can be written as 45 plus 30. Okay. So this is cos A, cos B minus sin A, sin B. What is cos A? Cos 45. Cos 45 is what? 1 by root 2, and cos B is root 3 by 2 minus, this is going to be 1 by root 2, and this is going to be half. So if you combine them, you get this. So this is how you get this pi by 4 plus pi by 6, 5 pi by 12, and cos theta, this theta is 5 pi by 12. So again this r is root 2 cos 5 pi by 12 by plus I sin 5 pi by 12. So let us summarize what we have learned. The number of this form a plus ib, where a and b, these are the real numbers. This is called the complex numbers. A is the real part and b is the imaginary part. If you take z1 equal to a plus ib and z2 equal to c plus id, if you add them, you get a plus I, b plus d. If you multiply them, you will get ac minus bd plus I, ad plus bc. And for any non-zero complex number, z is going to be a plus ib. There exists actually a by a square plus b square plus I minus b by a square plus b square, which we call it as 1 by z or z inverse, which is called the multiplicative inverse of z. Like this a plus ib, which is multiplication of a, this one, we will give you 1 always. You can write it as 1 plus I0. We call it as a multiplicative inverse. And just to learn that I to the power 4k is 1, I to the power 4k plus 1 equal to I to the power 4k plus 2 is equal to your minus 1, and 4k plus 3 is minus I. So the conjugate of the complex number z is equal to a plus ib. This is noted by z bar, and z bar is actually equal to a minus ib. And the polar form of this complex number z is equal to x plus I is r cos theta plus I sin theta. This r is going to be under root x square plus y square, the modulus of z. And cos theta is what? X by r. Sin theta is what? Y by r. And theta is known as the argument of z. And if the angle theta is between minus pi and pi, it is called as the principal argument of z. So the polynomial equation of n degree has n roots. And we have already also talked about the quadratic equation ax square plus bx plus c. If at all the b square minus 4ac, that is the discriminant, is less than 0, then we have a solution. Earlier we thought that it won't have any solution, but now it has a solution. So this is the solution. So thank you so much. This was all about complex number and quadratic equation.